since you had a quiz.
Oh, man. Weird.
Okay, I know a couple of you are still working on the quiz, and that is fine. Please feel free to take as much time as you need. But I'll actually set it aside for a minute now, and we're going to start looking at some of our material. Actually, what we're going to talk about first today is nothing terribly new. I want to talk a little bit about the ratios again, review some of the ratios and some applications, just because I really think ratio and proportion is the single most important topic that we learn in this course. And I want to make sure that you have it down. So we have that gear right there. And it's going to mess with another gear. First thing I want to ask, of course, is how many teeth does this gear have? 12 teeth. Okay. And let's say that the motor is hooked to that gear. Now let's say that we need to accomplish a let's do it the easy way since I'm brought to scale. Let's say we need to accomplish a 1-to-2 gear ratio. How fast is that smaller, or first of all, how many teeth are going to be on that gear? How do you get that? That's 1-to-2. 12 is the driving gear, right? So that goes on bottom. 1 times 12 divided by 2 gives us 6. Perfect. Leave yourself a little bit of space there. We're going to do one more example. Let's say that this gear here has 36 teeth. It's a fine tooth gear. And we need a 13:9 gear ratio. How many teeth are going to be on this gear? Where's the 36 going to go? Bottom. It is attached to the motor, so that makes it the driving gear. It's always driven over driving. We cross, multiply, and divide. 13 times 36 divided by 9 gives us 52 teeth in that gear. Again, I'm going to leave just a little space. Thank you. So now for this one, let's say that I tell you that this one has 24 teeth, and we need to accomplish a 6:11 gear ratio. How many teeth do I need on that other gear? Where's the 24 go? Top. It is the driven gear. So now we cross, multiply, and divide. We get how many teeth? 44. Very good. Now I'm going to step back. Back up to this first example. This was 6 teeth. If this motor runs 600 RPM, how fast is this gear going to go? Now, this was what we call, remember, this was a direct relationship. The bigger number in the ratio corresponds to the bigger number of teeth. They're directly related. The number of teeth gets bigger, the other number of teeth has to get bigger. When I'm relating the RPM compared to the size of the gear is an inverse relationship. This smaller gear, will it turn more or less RPM than the bigger gear? It'll turn more RPMs. It'll turn faster. So fewer teeth, more RPM. Inverse relationship. Number of teeth goes down, RPMs goes up. So we don't handle that with a proportion like this. We handle that with a product. It's the number of teeth times the RPM. 12 times 600 has to equal 6 times whatever that RPM is. If we cross multiply and divide, we're going to get 1200 RPM. Make sense? Now your textbook or your packets and your textbook set up inverse relationships using a proportion. I really dislike it because it's not a proportion. You don't have the horizontal and vertical connections that you're supposed to have. But what they do is this. You got 12 teeth compared to 6 teeth, right? And what they do is, since it's an inverse relationship, the 600 RPM goes with the 12-tooth gear, correct? But since it's inverse, they put it down here. Doesn't make much sense to put it there, right? It links to the 12. But they put it there so that it's going to multiply the 12, so it's going to do this multiplication here. To me, it makes more sense. An inverse relationship, you're multiplying them. Direct relationship, you're doing ratios. I just wanted to show you that just so you understood why the book was showing you a proportion for those, and it was weird. All it's telling you to do is whatever goes in this ratio over here, put it in upside down. So for this one, let's say that this motor is turning at 1,040 RPM. How fast is that gear going to go? Tell me how to set it up. (36 times 1,040), okay, equals 52 times x. So you're going to multiply 36 times 1,040 and then divide by 52, which is going to give you 720? 720 RPM. Get confused, right? Got her? Well, try this one in your notes. If the motor is turning 1,440 RPM. Hey guys, hands off each other. How many RPM is this gear turning? Find that one in your notes quick. What did we get for it? What is it? 2640. Do you guys concur?
I like your drawing there.
Anyway, we can have more complex ratios. Actually, let's go into this one. Let's look at I'm going to cheat. Let's get back here. Okay, so let's start out with this. Let's say we've got two similar triangles here. In other words, the big one is just an enlargement of the little one. We're going to say that's 8 inches. This is going to be 14 inches and 16 inches. Let's say this here becomes 12 inches. And I'm just going to tell you that the two are in the same orientation, that I haven't rotated them or flipped them or anything, just so that we don't have to mark the angles. How would I find the size of side X, the length? Okay, I need to find two sides, two corresponding sides that we know the length of in both triangles. Do we have that pair? Yeah, 8 and 12, they're the same side. The 8 is before the enlargement, and of course the 12 is after the enlargement. So we have that relationship. 8 goes to 12. The 8 became the 12. Now if we're trying to find X, is X going to go on top or bottom? Why does it go on bottom? It's from the same triangle as the 12, so it has to go with the 12. Perfect. What's going to go above it?
Are you serious right now?
What goes above it? 16. Why does the 16 go above it? Because it's the side of the before the enlargement, the same side of the other triangle. So 12 times 16 divided by 8 is going to give us 24. That is 24 inches. Very good. Find y in your notes quick. You sure? Okay. So yes, it is 21. We have the 8 over the 12 still. Where's the y go? Still goes on bottom because it's still from the same triangle as the 12. And above it would be the 14. And yes, when we cross multiply and divide, we do get 21. Let's say that this here is 4, 8, 10, x, 50, y, z, and 40. We need to match up our sides here. Yeah. We're not building something. We're just looking at shapes. Maybe that's a lot that looks like that. You have to find the size of the lot. Who knows? I've seen lots that are just as bad as that, especially if they're going around water features or anything like that. So anyway, can you find the pair of sides that corresponds that we have the length in both figures? Which one? Okay, z matches with the 50, okay, but we don't, so we're missing the z on that one. The 4 matches up with the 10. Z does not match up with 50, does it? Drew is wrong. Z matches up with the 40. What does the y match up with? That matches with 50. And of course that leaves the 8 matching with the x. How do we know that the 4 matches with the 10, by the way? It's next to that angle, so it's next to that angle. We use the angles to tell us. So which pair do we have that we know the length in both figures? 4 to 10. So now it's easy. We got everything's already paired up. We're going to find x first. Where's the x going to go? Bottom. And what's going to go above it? 8. X is from the same figure as the 10, so it goes on bottom with the 10. And the 8 is the corresponding. So you cross multiply and divide, you'll get 16 for x. Now we're still going to stick with the 4 to 10. Let's find y. Where's the y going to go? Y is from the same figure as the 4, so the y goes on top. Of course, it corresponds with the 50. So go ahead and find the length of y, and then find the length of z quick in your notes. It's not 16, is it? It's 20. You're right. Good catch. There you go. X will be whatever I tell it to be, darn it. Hey Drew, you got Y and Z already?
Yeah, it's Z is 100 and Y is 125.
No.
Y,
Look at them.
there we go.
Which one's bigger, Y or 50? Y better be smaller than 50, right? There you go. I know what you're doing. I just... So what's Y become? 20. Z is going to become 16. Very good. Any questions on those? Okay, so now okay, that didn't come up very close at all, did it? Find X and Y in that one quick. What'd you guys do to get this to work out? Okay. So the 5 feet and the 1 foot 3 inches are related. Good. Then what do you do? I would probably do 60 inches and 15 inches to make it easier on me. So now do you want to find X or Y? Let's do X first. X goes with the 5 feet, so it'll go on top. 1 foot 7, we're going to make 19 inches. So cross multiply and divide, and we'll get what? X is 76 inches. Now we really should convert it back into feet and inches. 6'4". What'd you get for Y? 1 foot 11. Perfect. Okay, I'm going to give you guys some homework to work on here for now, and then we'll come back to our second hour.